So this video is designed to help you with slide A and slide C. First, we're going to talk about our warm-up. Our warm-up says, what is the volume of a giant cube that measures 10,000 kilometers on each side? Use powers of 10 and your knowledge of exponents in your response. So the first part of this that I want to talk about is volume, because you may or may not have thought about how to measure volume recently, and that might be something that's getting you a little bit stuck. As you can see in the drawing, we're looking at a 3D shape, and that stands for three-dimensional. So volume is always 3D. So when we look back and we think about how to measure shapes, we can measure length, which is one-dimensional. We can measure area, and then our 3D shapes, we measure volume. So if we think about our unit here that they gave us, kilometers, for a length, we would measure a certain number of kilometers. But once we get to area, we would have to measure in square units. And you can imagine if I wanted to describe the space inside this square, I would have to count out how many smaller squares could kind of pave that two-dimensional shape. So we already said volume is three-dimensional. So area is two-dimensional, and length is one-dimensional. An area, we couldn't just say we're measuring it in kilometers. We would have to say we have a certain number of kilometers on this side and a certain number of kilometers for the width. So area we would measure in kilometers times kilometers, otherwise known as square kilometers. For volume, since we're looking at a 3D shape or three-dimensional, we would need three lengths. Okay, we would need to know kilometers, kilometers, and kilometers. So we would be multiplying those three lengths and measuring the inside of that shape with little tiny cubes. So we would end up with cubic kilometers. So now that we've reviewed the idea of volume, let's reread the problem and see if that helps us understand what's happening here. So the warm-up says, what is the volume of a giant cube that measures 10,000 kilometers on each side? Use powers of 10 and your knowledge of exponents in your response. So far we've done some thinking about what volume really means and understanding the first part of this problem. But we have not yet used our knowledge of exponents or powers of 10 in our answer. So let's now review, what do we mean when we say powers of 10 that we've been speaking about for the last few days of our lessons. So let's clear our workspace here. We've warmed up on volume. We know we're looking for 3 dimensions, something to the third power. Now let's think about, what do we remember about powers of 10? So we talked before about place value and about how our whole number system is based on tens, right? And when we're not sure how to start, you can always start with kind of the lowest, most friendly numbers. So let's think about, what is 10 to the first power? And we remember that our exponent here in blue, our exponent tells us how many factors we'll have that are 10. So this means we have one factor that is 10. So that equals 10. And then we'll work our way up. When we have 10 to the second power, we're saying we have two factors that are 10. So we have 10 times 10. And you can think about what number would that be equal to. Next, we have 10 to the third power, which would be 3 factors that are 10. So 10 times 10 times 10. What would that be equal to? And when you've thought through that pattern, remembering that our exponents in blue, and let's just review that word to remind ourselves, exponents, tell us how many factors that are 10 we will have. And when we write this all together, we have a power of 10. So right now, I want you to pause and think about how could we express the number that they gave us, 10,000 kilometers. How could we express that as a power of 10? So now you've figured out how can we represent 10,000 kilometers as a power of 10. Like that power of 10 I have circled at the bottom of your screen. And once we know that power of 10, we can connect back to our idea of volume and think about what will we need to do with that power of 10. So the expression that you end up with in order to solve your warm-up might look like to the third power. Because remember, we said volume is 3-dimensional, which means we need to multiply 3 lengths, and since it's a cube, they will be the same length. So your answer might end up looking like whatever power of 10 we used to represent the side length raised to the power of 3. Or you might have an answer that looks different. But either way, our units are going to have to be cubic kilometers. Because if we want to measure volume, which is the space inside of something, we would need to measure it with little cubes, right? It's a 3D shape. Now that we've spent some time really deeply thinking about our warm-up and the context of measuring the volume of a cube, let's relate that to our Explore section on slide C, where we have a second problem that talks about this concept of a cube and finding volume. So this problem says if you took the amount of oil consumed in 2 months in 2013 worldwide, you could make a cube of oil that measures 10 to the third power meters on each side. How many cubic meters of oil is this? Do you think this would be enough to fill a pond, a lake, or an ocean? So this problem is asking you to do 2 things. Number 1, connect back to what we know about volume, so you know what to do with that 10 to the third meters. And finally, you're going to be thinking about, okay, well, how big is that number? And how does that relate to these other bodies of water that you know about?